This is Donna at Magellan. I'm going to do a quick video on understanding fractions and simplifying fractions because it is a really common problem that we have. So I'm just going to look at some fractions really quick. And don't look at like these little cards. They have this side. This is a domino set, but you can see on here, if I were going to look at what fraction that is, okay, this is fractions are a part of a whole. So what part of a whole is red? The whole is 1, 2, 3, 4, 5, 6. The part of the whole that is red is 3. So 3 out of 6 are red. Okay. Can you look at this and see that 3, 6 is also half, right? So if I take out these little triangle pieces here, I can see that half of the red are covered. Well, how do I know? Number one, I can look at 3, 6 and see that 3 is half of 6. So I know that 3, 6 is 1/2. Other numbers would be 50 100ths, 25 50ths. Anytime I have the number on top is half of the bottom number, it's just half. Numbers are not fractions. So how can I have a classroom full of 10 people and half of them are missing and half of them would be 5? Well, if I have a classroom of 20 people and half of them are missing, half would be 10. Well, if I have a classroom of, let's see, 4 people and half of them are missing, then 2 of them would be, well, how can half be 5 and half be 10 and half be 2? It's because fractions are not numbers. They are quantities of another number. So half of 10 is 5 and half of 20 is 10 and half of 4 is 2. Fractions are quantities, not numbers. So that is the first thing that I see kids doing a lot of. This one is 2 out of 4, and half of 4 is 2. So this one is also half. This one, okay, you can see I have 1, 2, 3, 4. 4 out of how many total? Some kids say 8. That's wrong because I'm looking for the total. So if I count by 4s, 4, 8, 12. This would be 4 12ths. Okay. And if you look at the way these are set up, I have a whole line of 4 here that's red. Well, this is 1 line out of 3 lines. So 4 12ths is also a third. Okay, well, I can look at, when I'm making equivalent fractions, if I'm making them equal, whatever I do to the top, I got to do the bottom. So if I want 4 to be 1, what would I divide 4 by to make 1? I would divide it by itself. 4 divided by 4 is 1. Well, if I do that on the bottom, I also get 12 divided by 4 is 3. Okay. If I look at this one, 2, how do I get 2 and 3 to 1? Well, I got to divide them by themselves. Divide them by themselves. And I can check it to see the math works out. 6 divided by 3, count by 3 until you get to 6. 3, 6, it would be 2. And 4 divided by 2, count by 2 until you get to 4. 2, 4 would be 2. Okay, here's another one. This fraction is 2 out of how many? 1, 2, 3, 4, 5, 6, 7, 8. 2 eighths. Well, if I look at this, I don't have a whole red. I can look at it this way. I have a whole line here of red. 1, 2, 3, 4. And there's 2 out of 4. And that's going to be the smallest I can make it. Now, I'm sorry. That's wrong. I have one line out of 4 lines. 1 line out of 4 lines. Some of math is making mistakes too and being able to find them. All right. So 2, how do I get 2 to 1? I'm going to divide it by 2. And on this one, I'm going to divide it by 2. So 2/8 is 1/4. I'm going to do one more. Okay, this one. I have 1, 2, 3, 4, 5, 6, 7, 8 out of 4, 8, 12. Okay, and I can see I have a whole line of red here. One line, two lines. Oh, I can make this thirds. Oh, wait. 12 divided by what is 3? 12 divided by what is 3? 3, 6, 9, 12, 4. So I'm going to divide this one by 4. 8 divided by 4. Count by 4 until you get to 8. 4, 8, 2. And if I look, I definitely have 2 lines out of a total of 3 lines. That's just going to help you visualize it, but the math works out also. So the next thing I'm going to teach you is this. A lot of times kids are really confused with least common denominator and greatest common factor. So I'm going to argue that you don't really have to think about it in terms of greatest common factor and least common denominator, even though it does make it easier. There's another way to think of it, and that's with prime numbers. So prime numbers are numbers that are only divisible by 1 in themselves, and they repeat over and over and over. So they're never going to change. They'll always be that way. There are certain numbers that they can only be divided by 1 in themselves. And if you really think about it, that's what you're trying to get these fractions to. When you're simplifying a big fraction, like if I have 24/36, and we'll come back to this one later, and I'll show you a couple ways to do this. If I'm trying to get this to its smallest number, and if you look, the ones that I got to the smallest numbers, they all have something in common. The thing that they have in common is they all got to 1 or a prime number. Okay, so if I can get all of my fractions to a prime number or 1, that would be the ideal way to do it. So I can do that by using my prime numbers. So I'm going to teach you how to do that. Well, we say that 1 is itself because the rule is that it has to be divisible by 1 in itself only. And 1 is itself, so we say 2 is not prime. 1 is not prime. 2 is the only number that is a prime number that is even. Because we're going to talk about divisibility in just a second, because I'm going to bounce back and forth between this and another paper. 2 is a prime number because it's only divisible by 2 in itself, or by 1 in itself. 2 is itself. So if I'm looking for something that 2 is divisible by, I couldn't go to a number that was bigger than it, because if I do 2 divided by 3, which is just 2/3, because fractions are division problems, this is exactly the same as 2 divided by 3, I'm going to get, this is less than 1. This is 2 out of 3. This is less than 1. 1 whole would be 3/3. Well, I can't get that when I'm dividing 2 by a number that's bigger than itself. So we're not going to look at any of the numbers that are bigger. We're only going to look at the numbers that are smaller than it. 3, is it divisible by 2 or 1? It is divisible by 1. Everything's divisible by 1, but is it divisible by 2? No, 2 and 3 are not compatible, and those we can use 2 and 3. Basically, if you cut any fraction by 2 and 3 over and over and over, you're going to get to the answer. So 3 is prime. 4, wait a minute, 4 is divisible by 2, because I can count by 2 to get to 4. So that's not, oh wait. So if I think about my 2's, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. All these numbers have something in common, and that is that they end in 2, 4, 6, 8, or 0. Okay, hold up. So I can take out anything that ends in 2 is not going to be prime. So I can go ahead and take those completely out. And I can take out any number that's divisible by 4. That has a 4 at the end. These are not all divisible by 4. They just have a 4 at the end. I can take out any number that has a 6 at the end because I know it's divisible by 2. I can take out any number that has an 8 at the end because I know it's divisible by 2. I can take out any number that has a 0 at the end because I know it's divisible by 2. Now, if it ends in a 0, it is also divisible by 10. So not only is this divisible by 2, it's also divisible by 10. And the next thing I'm going to take out, 5, is not divisible by 4. It's not divisible by 3. It's not divisible by 2. I can't count by 2 and get to 5. I can't count by 3 and get to 5. I can't go by 4 and get to 5. So 5 is prime, but everything under it, 5, 10, 15, 20, 25, 30, 5, 10, 15, 20, 25, 30, 35, 40. All these numbers are divisible by 5, so I can get those out of the way. I know those are not prime. Okay, 7. I can't count by 6 to get to 7. Can't count by 5 to get to, we get 5, 10, 4, 8, 3, 6, 2, 4, 6. I cannot count by any number smaller than 7 to get to 7. So it's prime. 9. It's odd. It's an odd number, but I can count by 3 to get to 9. So that one's not prime. 11. 11 cannot be, you can't count by any of these numbers to get to 11. It's prime. 13. Okay, now we're going to start some different kind of conceptualization of prime numbers. So I'm going to go to this page. I made this already and kind of just scribbled it, okay? But stay with me. So, these are all of the threes. This is just the 3 song. If you know the 3 songs, this is all numbers that are divisible by 3. Okay, and these are, I'm just going to put these all out here. And I'm going to show you kind of some math tricks. Some people have already seen this, and I'm going to take it just a step farther so you can see some of the ways that these numbers go together. All right, you've probably already seen the 9s, and I don't teach the 9s trick. Right? If you go 9, 9 times 1, 2, 3, 4, okay, and then because kids go like this. So it doesn't really help them if they mix it up. So here's what I teach. Okay, if I want to know something that's multiplied by 9, if it's being multiplied by 9, okay, I'm going to go down 1 for the tens place. 9 times 4, I'm going to go down 1 for the tens place. And something else really interesting happens with 9s. 9 plus 0 is 9. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. Oh, wait, I don't actually have to do any of the rest of these and add them up. They're all going to add up to 9 because 45 is 54 backwards. 36 is 63 backwards. 27 is 72 backwards. 18 is 81 backwards. And 9 is 90 backwards. That backwards thing only works up to 10, but the adding up to 9 thing, that works forever and ever and ever. So let me just do this. Is that number divisible by 9? Well, the only way to know if it's divisible by 9 is to add up all the digits. And I don't have to add 0. 1 plus 3, 4. 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I get 27. And I'm going to keep adding until I get 1 digit. 2 plus 7 is 9. Any number that is divisible by 9 will add up to 9. So now that you know the 9s, and so if that's true, if I want to know what 9 times 5 is, I'm going to go down 1 for the tens place, and then I'm going to add to get to 9. So if I want to know what 9 times 7 is, what's being multiplied by 9? 7. Go down 1 for the tens place, and then what plus 6 equals 9? 6, 7, 8, 9. That works. This little rule works all the way up to 10. So let's talk about threes. This is all going to make sense. It's going to all go together and it's all going to make sense. What we're doing is we're looking at statistics. Statistically, this stuff is not going to change. It is forever and ever. And if you can memorize these rules and use them on the day-to-day basis, then it will help you. Well, I don't have to add these to get to a single digit because I know they are. So all these are divisible by 3. 1 plus 2. Let's see if you can see the pattern. 1 plus 2 is 3. 1 plus 5 is 6. 1 plus 8 is 9. 2 plus 1 is 9. 2 plus 4 is 2 plus 1 is 3. 2 plus 4 is 6. 2 plus 7 is 9. 3 plus 0 is 3. 3 plus 3 is 6. 3 plus 6 is 9. 3 plus 9 is 12. And 1 plus 2 is 3. I want to get it to one digit. 4 plus 2 is 6. 4 plus 5 is 9. 4 plus 8 is 12. And 1 plus 2 is 3. 5 plus 1 is 6. 5 plus 4 is 9. 5 plus 7 is 12. And 1 plus 2 is 3. 6 plus 0 is 6. 6 plus 3 is 9. 6 plus 6 is 12. And 1 plus 2 is 3. 6 plus 9 is 15. And 1 plus 5 is 6. This is going to go until infinity. It will go forever. Every number that is divisible by 3 is going to make 3, 6, or 9 when you add up the digits. So we're going to use that. Why wouldn't we use that? 7 plus 5 is 12. 1 plus 2 is 3. 7 plus 8 is 15. 1 plus 5 is 6. 8 plus 1 is 9. 8 plus 4. Oh, that's right. 8 plus 4 is 12. And 1 plus 2 is 3. 8 plus 7 is 15, and 1 plus 5 is 6. 9 plus 0 is 9. So all of them will add up to 3, 6, or 9 when you add up the digits. Okay? Now, another thing that is really cool about this is that the 9s are here because it adds up to 9. So anything that adds up to 9 in the 3 song is divisible by 9 also. So it's not only divisible by 3, it is also divisible by 9. And they're right here. Okay. So if a number is divisible by 9, is it divisible by 3? These numbers are divisible by 9. They're also, all of these are divisible by 3. If a number is divisible by 3, it is not always divisible by 9. So you can be divisible by 9 and divisible by 3, but not every number that is divisible by 3 will be divisible by 9. The next thing I want to show you is 6s, because in 3s we also get 6s, and it's really every other one. 3, 6. 6, 12, 18, plus 3, plus 6. 24 plus 3 plus 6. 30 plus 3 plus 6. 36, 6, 12, 18, 24, 24, 30, 36, 42, 48. It's going to be every other one. And there's something interesting about the 6s, and that is this. Every number that is divisible by 6 is divisible by 3 and 2. So if it ends, and it's in the 3 song, and it ends in 0, 2, 4, 6, or 8, it will also be divisible by 6. Okay, so we're going to talk about that. And I'm going to break it apart in this other lesson. Now, if it's divisible by 9, it adds up to 9. If it's divisible by 3, it adds up 2, 3, 6, or 9. If it's divisible by 6, it has to be divisible by 2 and 3. Great rules to have. Now, 2's ends in 0, 2, 4, 6, or 8. If it's divisible by 5, it ends in 0 or 5. If it's divisible by 10, it ends in 0 only. Okay, so you kind of have an idea about that. Now, for these, if I'm looking at 13, do I need to look at, I mean, I know 13 is not divisible by 2, and I know nothing here is going to be divisible by 2, but I don't actually have to check for 4, 6, or 8, or 10, or 5, because I've already taken all those out. So I don't have to check for this one. I don't have to check for 5. I don't have to check for 10. I don't have to check for 8. I don't have to check for 6. I don't have to check for 4. So that only leaves me, on all these other numbers, to figure out if they're prime. It only leaves me 3 and 7. So I only have to check and see if these are divisible by 3 or 7. And I already know, number one, most of my 7s are going to be out of here. There are only a few. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77. Ooh, that reminds me about something. 77, 84, 91, 98, and 105. Now, for 7, so I would memorize my 7 song, because that will help you a lot. 7s helps you a lot. Now, and then the other one I want to take out of here are 11s, because I know 11s are pretty easy. Now, all of the 11s I took out are divisible by 3. So I would have found them when I got by 3s, but it's just easy to see that 11s. Now, unless it adds up to 3, 6, or 9, it's not prime. 3 plus 1 is 4, prime. 7 plus 1, 8, prime. 9 plus 1 is 10. That's prime, because it's not divisible by 3. 3 plus 2, prime. Oh, 7 plus 2 is 9. That's not prime, because it's divisible by 9 and 3. 9 plus 2, 11. Oops, sorry, that's prime. Gets to be 11, then it's prime. We're looking for numbers. We're getting all the numbers out that are divisible by 3. And everything else is going to be prime. 3 plus 1 is 4. 7, 8, 9, 10. Prime. 9, 10, 11, 12. Divisible by 3. 1 plus 2 is 3. 4 plus 1. Prime. 4, 5, 6, 7. Prime. 7, 8, 9, 10, 11. Prime. 5 plus 1 is 6. That's divisible by 3. 5, 6, 7, 8. That's prime. 7, 8, 9, 10, 11, 12. 1 plus 2 is 3. It's divisible by 3. 9 plus 5 is 14. Prime. 7 plus 1. It's prime. 6 plus 1 is 7. 67 is prime. It adds up to 13. 9 plus 6 is 15 when I add it up. 5 plus 1 is 6, so it's divisible by 3. 7 plus 1 is 8, prime. 7, 8, 9, 10, prime. 9 plus 7 is 16, and 1 plus 6 is 7. This is prime. 8 plus 1, that adds up to 9, so that one's divisible by 9 and 3. 8, 9, 10, 11, prime. 8 plus 7 is 15, not prime. 1 plus 5 is 6. 9 plus 7 is 17. I'm sorry, 9 plus 8 is 17. I'm getting ahead of myself. 9, 10, 11, 12, and 1 plus 2 is 3, so that one's divisible by 3, and 9 plus 7 is 16, so 1 plus 6 is 7. So if you look, there's really not a lot of numbers that are prime. There's not. So if we really think about it, and I memorize 2, 3, 5, 7, 11, that will get me through simplifying a lot of the fractions. Like especially, where's the piece of paper I had? Like if I had 24, 36, a lot of times they'll be like, okay, list all the factors of 24 and 36 and find the, find, what are they both divisible? Okay, you don't have to do all that. Cut it by 2 and 3 until you can't cut it by 2 and 3 anymore, and you will find the simplified fraction. These two numbers, the first thing I'm going to look at is the first prime. 2, 3, 5, 7, 11. They both divisible by 2? They both end in 4 and 6. They are both divisible by 2. And memorizing halves of odd numbers is going to be really, really useful to you. 24, half of 20 is 10. Half of 4 is 2. And if I add it up, I will get what half of 24 is. 10 and 2 is 12. 36, what's half of 30? Half of 30, if you think about a clock, okay, here's 30 minutes. Half of 30 is right there. It's 15. So 15 and half of 6 is 3. 15 and 3 is 18. 18. Half of 36 is 18. Now, these two numbers, let's look at these. Can I get it any smaller? Remember, I'm trying to get to a prime number or 1. And I know my prime numbers are 2, 3, 5, 7, 11, 13, 17. Okay, I'm not anywhere near any prime numbers. 12 and 18, both divisible by 2. 12, half of 12. Half of 10 is 5, and half of 2 is 1, and 5 plus 1 is 6. So half of 12 is 6. 18, which you should already know. If I'm just going to divide that by 2, I can count by 2 until I get to 12. 2, 4, 6, 8, 10, 12, and it would be 6. But if you don't know that, half of 18, half of 10 is 5, and half of 8 is 4. 5 plus 4 is 9. Half of 18 is 9, and if I count by 2 until I get to 18, that will get me to figure out what the half is. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, now, are these both, always check, are they both divisible by 2? That one is, but that one's not. So I'm going to go to 3. Divide it by 3. Both of them are divisible by 3. Count by 3 until you get to 6. 3, 6. Count by 3 until you get to 9. 3, 6, 9. 3, 2/3 is the answer. Here's another way you could have done this, and this is how you can do it. I can cut it by 2 twice. That would be like cutting it by 4, because they are both divisible by 4. 24 divided by 4. 4, 8, 12, 16, 20, 24. That would give me 6. 36 divided by 4. 24, 28, 32, 36. That's only if you know your 4s. If you don't know your 4s, do it this way. Okay, I would still get to the same answer, and then I would have to cut it by 3. Okay, so that's going to help you tremendously. Now, 4s. How do I know if a number is divisible by 4? And this is the only way. If a number is divisible by 4, and I guess I'm just going to take the rest of this paper. If a number is divisible by 4, and I'm going to show you these two. These are all my 4s, okay? How do I know if a number is divisible by 4? To know if a number is divisible by 4, I look at the last 2 digits, and if it's divisible by 4, then the whole number is divisible by 4. So 432. All I'm going to look at is here, because it doesn't matter. This number here is 400. So really, I have 4 hundreds here, and 100 is divisible by 4. There are 4 quarters in a dollar. So 100 divided by 4 is 25, 25, 25, and 25. There are 4 25s in each 100. And so if you think about it, it doesn't even matter if I have an odd number of hundreds. And I'm going to show you that in a second. Okay. 400 divided by 4 is 400 divided by 4 is 100. Because here's 400 divided by 4. And then 32 divided by 4 is 1, 2, 3, 4, 5, 6, 7, 8. So 108 is 432 divided by 4. You don't have to understand this. What you need to understand is to know if something is divisible by 4, I just look at the last 2 digits. What about 324? Well, 24 is divisible by 4. 1, 2, 3, 4, 5, 6 times. Okay. And 300, is it divisible by 4? Yes, it is, because it is really 300, and each 100 is divisible by 4. Don't think about it being an odd number. So just remember that all you're looking at is the last 2 digits when you're dividing by 4. So how about, what if I had 3,024? I'm still just going to look at this one. Let's say I even have this, 3,324. Well, 3,000s, 1,000 is still divisible by 4. 1,000. I have 3 of these 1,000s. 1,000 is 250. 1,000 divided by 4 is 250. And then, of course, my 3, I would have this here. Okay, I would have 3. Okay. So I don't actually have to do that. All I'm doing, when I'm doing this, I just want to see if this number is divisible by 4. And then I can do whatever I need to figure out how to divide it by 4. If I want to just go and divide it by 4. Okay, but if I want to know if a number is divisible by 4, if I can do it, that is usually the biggest hurdle that kids come to. So divisible by 3, it adds up to 3, 6, or 9. Divisible by 9, it adds up to 9. Divisible by 6, it adds up, it is divisible by 2 and 3. If it's divisible by 2, it ends in 0, 2, 4, 6, or 8. If it's divisible by 5, it ends in 0 or 5. And if it ends in 0, it's divisible by 10. And then 4s, something else that I noticed with 4s is this. Every time it has an even tens place, okay, if it has an evens tens place, let's look at that. Okay, the numbers that have an evens tens place, they count by 4 and 8. The ones that don't have an evens tens place count by an odd number. I mean, they count by 2 and 6. The ones that start with an odd. The ones that have an even tens place count by 0, 4, and 8. The other ones do not. Even tens place, 0, 4, and 8. The other ones do not. Even tens place, even tens place, even tens place. Now, so I tell kids to look for this. If it's 20 in the 20s, the 40s, the 60s, or the 80s, it's going to count by 20, 24, 28, 40, 44, 48, 60, 40, 64, 68, 80, 84, 88, 100. Okay, now look, if, so if it's 54, well, that one's counting by 4s. The last one before it would have been 50, and I'm never going to get to 50 here because it's an odd number. So anyway, I hope this helps you to figure out divisibility, because I think that is really hard for kids to figure out. Prime numbers. Memorize them. 2, 3, 5, 7, 11. Okay. And when you're simplifying, your goal is to get to a 1 or a prime number. So if I get to a prime number, like let's say that I have 216 570ths. Most kids would freak out. Don't. 2, 3, 5, 7, 11. Those are my prime numbers. That's what I'm going to use to simplify this. Are they both divisible by 2? Yes. Both divisible by 2. Okay. What is half a 200? 100. What is half a 10? 5. What is half a 6? 3, and then I'm going to add it up. 208. Sorry. 108. 108. Okay. 570. What is half of 500? Half of 500 is 250. Half of 70. Well, hold on. Here's how I teach kids 70. 7 times 10 is 70. Well, half of those would be times 5. What's 7 times 5? 35. Half of 70 is 35. And I don't have to do that ones place. I'm going to add it all up. 285. I'm going to go back to 2. Are they both divisible by 2? This one is, but that one's not. Okay, what do I do? Check 3. Are they divisible by 3? 1 plus 8, I don't have to do that, 0. 1 plus 8 is 9. 2 plus 8 plus 5, hold up. 8 plus 2 is 10. Is 50. Oh, 1 plus 5 is 6. Yes, I get 3, 6, or 9 when I add up these digits, and so these two numbers are divisible by 3. So I'm going to do 108 divided by 3. And I'm going to do 285, and I'm going to divide it by 3. 3 can't go into 1, it can go into 10. 3 times 3 is 9. 10 minus 9 is 1. Bring down my 8. 3 goes into 18. 3, 6, 9, 12, 15, 18. And if you don't know the math songs, they're on here too. Just go look at the math songs and you learn these math songs. It will help you a lot too. 3 times 6 is 18. I get 0. Oh, 108 divided by 3 is 36. Okay. 285. 3 can't go into 2, but it can go into 28. Right? 3, 6, 9, 12, 15, 18, 21, 24, 27. And I can't go any higher because I have 28. That's 9. 3 times 9 is 27. 28 minus 27 is 1. And I'm going to bring down a 5. 3 goes into 15. 3, 6, 9, 12, 15. 3 times 5 is 15, 0. 285 divided by 3 is 95. Now I'm going to go back to 2. Always do 2 and 3. Cut it by 2 and 3 until you can't anymore. And if you have to do 5, great. Now, this one's divisible by 5, but that one's not. So I'm not even going to look at it. You can do 5, get it out of there. But you can't do 5 because you have to do the same on the top and the bottom. So is it divisible by 2? This one is. That one's not. 3, 36. Divisible by 3? 3 plus 6 is 9. 9 plus 5 is 14, and 1 plus 4 is 5. These are not compatible with 2 or 3. You are done. There's nothing else you can divide this by. If you can't divide it by 2 or 3 anymore, you're done. Now, I don't have a prime number, but this one in particular I showed you because you don't have a prime number, but you're also not compatible. 2 and 3 are not compatible. You will never get to the bottom of this number. This number is going to be this number forever. All right. So I hope this helps you. And if we want to see more simplification, I think that would also be helpful. Go learn those math songs. That will help you a lot. You should be able to count by 2s, 5s, and 10s pretty easily. If you will learn 3s and 4s and 7s, those are, if you don't know any of the other math songs, if you know 3s and 4s and 7s, that will help you a lot because you can use the multiplication. You can use this for 9s. Okay, let you just go down 1 for the 10s place and add to get to 9. Okay, so 3s, 4s, and 7s will help you tremendously because if you know 3s, then you know 6s. So 3s, 4s, and 7s. And if you know 4s, you know 8s. So we'll learn 3s, 4s, and 7s because you should already know 2s, 5s, and 10s. Those should be pretty easy. Okay, and if you know 8s, or if you know 4s, you know 8s, and if you know 3s, you know 6s because you can just count every other one. So I hope that helps to give you kind of a basis. That was a good 40 minutes. So if you ever need anything, you just let me know, and I will be happy to make a video on it. I hope that helps and didn't confuse you. Bye.